Okay, everyone, this is Rico, and today's project is a DE0 Nano, and the idea is to put the Nios II CPU on it with the Hello World small application. And I'll be using Quartus Prime 18.1 Lite Edition, and they have a ton of application examples out there, but they were released when the board was released a number of years ago, and they're kind of dated, and I was trying to program it, kind of was pulling my hair out, and decided to document how I did it after a number of different tries to finally sort it out, because I was kind of learning and doing it at the same time. So anyhow, this is what I came up with. Let's see, System Builder, and I have a folder here that I wanted to use called Nios Project for this video demo, and I'm going to call it NIOS. Let's see, call it the same thing as the folder here, project in this case. And I just picked a bunch of different little odds and ends that I will probably be filling with after I get this basic idea, the basic building block built. So clock is for sure important, and these other ones are optional, but same thing with the GPIO default header. Click generate and select that folder, which is E drive NOIS project, NOIS project.quartus project file or QPF. So save it, and once we do that, we'll be able to go to the E drive and that project folder, and there's the files that it creates. And we can close this. Now this is the Quartus program. If I double click that, Quartus will start running. These other ones are pretty interesting, like this HTML one gives you a report about the CPU that's being built, or not the CPU, but the project that it's being built, what items were selected in the project builder. So, and that's on the application CD when you get that, which is downloadable from Intel's website. So, but anyhow, there's those files. This is a key one, and then opens Quartus up here, and or you can open it and then select File, Open Project, and navigate to that folder and open this one. Either way, it'll result in the same thing. So this is, double click this guy, and then this is the structure of everything that we built. And the key thing that we really need for now is just the clock 50. And we want to put it in the structural coding. And this is actually from a step that's going to come here in advance, but we're going to build a SOPC, which is the actual CPU part, because this is the project part, and we'll call it uniform 0. And we're going to just define the clock to the clock 50. And that's really all you need to do there. And then open up the Platform Designer. I like to start saving right away. So we'll do a quick save. And then go to Tools, Platform Designer. And my idea here is to get a functional working building block as simple as possible. The only real major goal is that it works and produces some sort of tangible output, in this case, Hello Rico. So we open this up, and under the IP catalog here, we type in NIOS. Make this a little bit bigger. And scroll down, here's the processor, double click this. I'll add the processor over to here, and in this case you can just hit finish, and then we want to add an on-chip memory, which is this one. This one we want to go ahead and change this to 16384. And again, this is what worked for me, just to get it up and running. A number of different tutorials and whatnot had a range of different numbers, and some caused problems and some didn't. Again, I think because I'm a couple years behind on all this, but I wanted to play, so what the heck. JTAG UART is the next one. This is the UART that allows us to communicate to it with the PC, and we accept all the defaults and hit finish. And now the trick is to click all these and tie all these signals together. Come on. A little monotonous. Don't drink a ton of coffee before doing this one. Okay, so now those are all hooked together, and you can also, though, at this time, I won't go and do it right now, but you can rename these to things like CPU and things like that, or a lot of the videos that I've seen recommended at least take the trailing zeros off. In any event, once these signals are tied together, we want to tell the CPU to have a reset vectors. So you double click CPU, or on iOS 2, Gen 2 is the CPU. Select the vectors tab, and then here select the memory for the reset vector memory and exception vector memory on chip memory. Close it. And let's see, so there's renaming, tying them together, and the reset vectors. And then the next set is set base addresses. There's a neat little tool, assign base addresses. That one's quick. And then generate HTL. And then it says save it, so we want to save it. And in this case, in the previous step, I had selected SOPC, and that's really what we're making right now. We're making an SOPC. So SOPC is what this must be named, because that ties to the project file in Quartus. So it's sopc.qsys. So we'll save this in the same folder as before. We will get a notification once we get over to Quartus telling us that we have to add the QIP file. So we'll do that here next as soon as this is all done. And I just wanted to reiterate, this whole process is just to get a basic functioning work setup with the software that I can download today, which is 2020. So, and I've been trying this with success and failure and failure and failure and a little success, and I decided to make a good set of notes, and then I thought how cool it'd be just to have a video of it for others to benefit from. So that's kind of the idea here. Just kind of rambling while this takes a second. So we'll add the QIP, and that'll give us so we have the project container more or less. Now we have a CPU, so we'll close this. We can close this, and there's that notification. The QIP will create a generation directory synthesis SOPC. So that's what we named it. So we're going to do that process next. I found this one to be rather tricky to figure out, and the trick is change under the project navigator to files. Right click on the folder files, add remove, and then these three dots, and then pick the SOPC QSYS file. And again, that SOPC name, a lot of these names are real important. So, and then conceptually, you have the project, you have the CPU, which is what SOPC is. It's, I think it's something like system on a programmable chip or something, but it's basically the CPU. So hit open, and then apply and OK. And as we build it, you can see that's been added to our folder. So I kept this folder off to the side here so we can kind of follow along. So that's where SOPC ties the SOPC we just created, the CPU. So I don't know why they didn't just name it CPU, but so let's see what's next on my notes here. Now we want to fire up Eclipse. Eclipse is a software that allows you to write the code that the CPU runs. So this is the third and final phase of this stuff. So you have a FPGA file, you have a CPU file, and now we actually have the file the CPU is going to run. Took me a while to get this all in my head, but it's really cool. It's a lot faster than hand wiring a circuit board, which I actually love too, and I'll probably post another video of that with my Z80 project. The next phase of it anyhow. So here's this software tools for Eclipse. So we'll run this. And again, the goal is to get a basic output out of the sky. And then that's my first brick in the building process. So let's see, we want to go File, New. And again, the three dots. And it's now catching on to where paths are, NOIS project. And again, the CPU is called SOPC. And I actually wrote that somewhere, but that's the one we want. And that takes a second or two. So that'll come up. And then in this case, I'm going to give it the project name of Hello World. And Hello World. And the small version. And for now, everything's going in the same folder, but ultimately I'll have folders for FPGA files, folders for different configurations on the CPU, and then different software that I'm running on the CPU. So it'll be a little bit more organized. Right now, I just want one go-to, works every time setup. I've done this so many times in preparation for myself and for this video, which I'll probably wind up having to use it again because I'm getting forgetful. But does all this good stuff and compiles and builds, and we started getting more folders over here. This new folder here called software just showed up, and that's where it is over in our file structure, and that shows up here under the Project Explorer under Eclipse. So we right click here and we build it. Actually, want to stop this and actually expand this. Open up the C file here, Hello World small c, and say Hello Rico, just to show that I'm actually doing something on my own. Now I'm going to right click on it and build it. Hopefully I'm not clicking too fast. I watched these videos, different things, but one of them was these, and people click stuff so fast I couldn't tell what they clicked, and had to watch it like 3,000 times to try to figure out what they were doing. So I'm going to leave my comments open. I'm really looking forward to learning. I'm real amateur at YouTube, so if there's something I skipped or missed, just let me know, because I'm kind of looking forward to getting a dialogue going here. Seems like fun. So now the project's built, finished, and then now we run it. The way you do that is, again, right click on it, and you right click on the Hello World part, not the BSP part. But then you come down here and you click on Run as NIOS to Hardware. This takes a few seconds. Of course, we want to save everything a lot so we don't get the BOSD and then be pissed. Let's see here. I'm looking at my notes, and while this is crunching over here. Oh, this is actually good. So we built the FPGA file, we built the CPU, we wrote an application to run on the CPU, but I failed to remember to put the project into the actual circuit board, the DE0 Nano. So I'm going to open up the Quartus Prime Programmer, which you can access from either Eclipse or Quartus. In this case, I'm just going to do it from Eclipse, since I already have it open. So hardware is already found. It's already plugged into my computer. It's right here. If it's not right here, then there's a fairly well documented procedure on Intel's website to find it, but auto detect it. It's an EP4 Charlie Echo 22. Okay it, and it'll show up right down here. Bang, there it is. And then see here where it says file is none. Double click that, and we want to find the file, and then basically put it into the Nano. And so we're going to go to that folder, which is Nios project, SLPC, synthesis. Oh darn, let me look at my notes. We are looking for the SOF file. Let me go back a little bit here. Oh, I forgot to build that one too. So come back over to Quartus and build it. And this will take a half an hour, so I actually think I'm going to not edit out the mistakes, because those are the ones that you're going to run into, and when you see them in the video, you'll appreciate them, hopefully. So, because these are the ones where I pulled out most of my hair, what little I have left. So, anyhow, this will program, and then we should be able to find the file, and then put it into the Nano. Once it's running on the Nano, then we can go back into Eclipse and then run it, and what it does is it downloads it over the JTAG UART and then runs it, and then in this particular case it's a C program, which is essentially a princess string, and the way I understand it is it's standard out, standard error, goes over the UART. Got to learn about it, but that's what again, the whole point to this video is get a working building block that you can learn from. So I always thought FPGAs were really cool, and build a lot of things. And so kind of rambling along, waiting for this to go here. I did also discover that there is actually a board file, which is over here under Quartus. It's I like the ones where you can see the boards and drop the parts there, and actually seeing where the CPU showed up as a board file. So that's the next thing after this video, is going to start investigating that, because I wanted to be able to have a CPU and an additional logic hardware to do things like induction heating or other crazy stuff. So let's see if I can find this file now. I don't know if I may have to close this and reopen it, or let's see what it finds. Project, and there she is. Boom, just showed up right in time. So it says limited time, but I haven't noticed it. When you run it, you'll get a box that pops open. You have to check this box here, program and configure, and then start, and then you get this progress where it's bam, and then here's the box I was just starting to mention. It says time remaining unlimited. Anyhow, I just get this out of my face, and then go back over to this, and literally right now we now have a CPU that's running, waiting for our instructions, and here they are. And so now what we're going to do is, I believe I built this, so then we're going to now run it. So run as Nios II hardware, and there's another error that typically pops up right around now, and I don't recall if this is it or not, but let's see. There's one, and then I have some notes on how to fix that one. Let's see if it actually, bam, there it does, it ran. Alright, and I'll actually point out a note here on another error I found in case somebody runs into this one. There's a, if it pops up, it says the expected standard out device name does not match the selected target byte stream device name. Anyhow, there's a place where it says system ID checks, and you can ignore mismatched system ID and ignore mismatched system timestamp. Check those, hit apply, and rerun it, and it runs every time. And I know this is a real fast one, but the whole idea was to get something that works, because once I have something that works, I can then break it and then figure out what I did and learn from that and go on and go forth. So um, that's the project. And if you wanted to, just edit this and then build it again and then rerun it again. And so the next couple times I play with it, I'm gonna put some for loops in here, some more statements and stuff, and have it do some things, and then actually run it as I understand you can do debug as debug as NIOS hardware and actually debug. So that'd be the next thing I play with. But anyhow, hope you guys like this. And so Rico out. Have a good one.